Alright, welcome back. This is the second video for the reflection topic. Hopefully you benefit from the first video, and this one also helps. I mentioned there are some rules that you can use for reflection, and I'll briefly go through each one of these. These rules will help you if you have to actually reflect an object. Depending on the line of reflection, it will always follow these rules. So once you get the hang of it, all you have to do is change a certain value, flip the x and y, depending on what type of reflection you're doing. So essentially, you can reflect it over any line, but most of your questions will be pertaining to 4 specific lines of reflection. So you can reflect it over the x-axis, y-axis, the line y equals x, and the line y equals negative x. And I'll show you a couple examples, or hopefully I can do an example for each one of these. Alright, now if I use a line of reflection that's y equals x, which is in red, that's if you would have graphed y equals x, this is what that means. So if my line of reflection is that, how would that affect my shape? If this is my original shape in black with all my vertices labeled, if you follow the rule here, all it does is you switch each point. So if I'm to graph each one of these again, first of all I should let me label these points real quickly. I just labeled 2 of the points, and I'll quickly show how we can take our rule for the line of reflection y equals x and apply it to our image. Remember the image we start with, which is kind of weird vocabulary, so pre-image. Then once we take our reflection to that image, it becomes the pre-image. So using the line of reflection rules for y equals x, this tells me all I'm doing is switching my x and y. So if my first coordinate of a is 1, 3, if I flip that, it'd be 3, 1. So let me do that, and let's do it in blue. 1, 2, 3, 1. That would be my new a coordinate, a prime to be exact. And then b is 1, 5, so I flip those, it'd be 5, 1. 1, 2, 3, 4, 5, 1. So just that one portion of our square. The rest of the coordinates you do the same way. You just find what the coordinates for each point are, and then since it's reflected over y equals x, you just flip them and then regraph. That's my x here. So for instance, if I had a triangle here, if I reflect it across the x, a mirror image of it, 1, 2. I'm gonna guess. It would look something like that. These are equal distance from the line reflection. This should have been 2. That should have been 1, 2. The same distance. So if I had to plot these points, let's say if this was A, B, and C, these points down here, this would be B prime, A prime, and C prime. Now to get these coordinates, it's pretty easy using your rules here. So if I just look at A, if I did this correctly with my sweet drawing, 1, 2, 3, 4, 1, 2, 3. So A would be at 4, 3. And if I'm reflecting it over the line, if my line reflection is the x-axis, I look at my points. So if whatever I started with, my coordinate points is x and y, x and y. Then it translates to x, and then you take the opposite of what you have at y. So this new point for A would be the x stays the same. And then my y is just the opposite of whatever I have for y. In this case, it's 3, so I just negative 3. And that's that point right there, which makes sense. So whenever you have a line of reflection across the x-axis, essentially all you're doing, your x value is staying the same, and you're taking whatever the opposite of your y is. And if your y is down here at negative and you're reflecting across the x, then it becomes positive, or vice versa. It can still, the signs can be the same, but most of the time they'll just be reversed. So whatever you do, whatever coordinates you get, x stays the same, and then you just take the opposite of whatever you have for y. That's the x-axis. The y-axis is very similar. Instead of reflecting across the x, you reflect it across the y. So in this case, if I was doing this shape, it'd go over here. It still would be equal distance from the y-axis. And the only thing that changes now is your y value stays the same, but your x value is the opposite. And if our line of reflection is over y equals negative x, it's the same process. This one, the rule is a little different. This, you take the opposite, you flip them, both the coordinates, and then you take the opposite of each. Let me show you what the line of reflection of y equals negative x. Remember, this is y equals x. So the opposite of it is just that line. So I'm reflecting it across that line. So it works the same way. Whatever shape I have here, if I reflect it across this, all you need to do is get your original coordinates for each point, and then flip them, and then take the opposite. So that's basically the 4 rules for reflection. These should go in your notes whenever you have to reflect or move an object over an axis, over a line of y equals x or y equals negative x, so you can use these rules to quickly come up with the new points. And it always helps to draw some of these too. I like to draw grids. They help you visualize them, and if the grid's perfect like this, you can actually just count. It makes it much easier. But these rules are extremely important. Once you get these down, written in your notes, to help you solve most of the problems in that section. Hope that helps. I'm going to look over some of those questions. If there's a couple of ones that are difficult, I might throw some examples on at the end of this lecture or short video. I have to take a closer look at some of the questions to see what they're actually asking. But hopefully that gives you a better understanding of what reflections are. And I'll talk to you later.